All right, page 16, simplify each expression using the rules that you wrote. So we wrote the rules on page 14 and 15, so let's go ahead and continue on this page. We have 6 to the 4th power times 6 to the 3rd power. We know that we're going to keep the same base when we're multiplying, and since the powers are being multiplied, we're going to add the exponent. So it's going to be 6 to the being raised to the power of 4 plus 3. So 4 plus 3 is 7. So this simplified version would be 6 to the 7th power. So notice how it's not asking us to solve, it says to simplify the expression. So this longer expression simplifies to 6 to the 7th power. Same thing for B. We have 9 to the 7th power times 9 to the 8th power. So keep the same base. We add the exponents. So it's going to be 9 to the 7th plus 8. 7 plus 8 is 15. So the answer is 9 to the 15th power. For C, it will be a little bit different because the powers are being raised to another power. So in this case, we're not going to be adding the exponents. Instead, we're going to be multiplying the exponents. But we do still keep the same base. So the base is 4. So 4 being raised to the power of 3 times 5. We know that 3 times 5 is 15. So it's going to be 4 to the 15th power. Okay. And for this one, it would be 2 times 3 times, notice how we're simplifying, so to make our lives easier, let's change this 8 to with the base of 2. Okay, so it's going to be 2 to the 3rd power because we know that 2 times 2 times 2 is 8. So I just rewrote 8 with 2 to the 3rd power and still being raised to the 5th power. Okay, and we can combine them by multiplying the powers because this power is being raised to a different power. So we multiply. So 2 times 3 remains the same, but 2 to the 15th power by multiplying 3 times 5. And then once we simplify that further, we get 3 remains the same, but there are 2 to the first power, which is imaginary. There's no 1, but it's 2 to the first power is the same thing as 2. So we have 1 and the 15, which we add because 2 to the first power is being multiplied to 2 to the 15th, just like this example. We're going to have to add the exponent. So 1 plus 15 is 16. So 2 to the 16th power times 3. Okay, so this is the simplified expression from this. And E is 5 to the 5th power times 5 to the 2nd power times 5. So we can rewrite that as 5 to the 5 plus 2 plus 1. So if you have nothing on here as an exponent, that means it's going to be raised to the power of 1, just like these ones, right? So we're going to have to add them up. We get 5 to the 8th power. Right here, it's 2 times 3, all being multiplied, being raised to the power of 4. Meaning 3 times 2, we can do that, which is 6, and we can rewrite that as 6 to the power of 4. And so Raymond says that 2 to the 6th power is equal to 12. Randy says that 2 to the 6th power is equal to 64. Who's correct? So we can say that Randy is correct, right? Because Randy multiplied 2 by 6, Raymond multiplied 2 by 6, so that's how we got 12, instead of raising the 2 to the power of 6. So, which is, to solve 2 to the 6th power, we should do 2 times 2 times 2 times 2 times 2, 6 times, so to get 64. So Raymond's method, where he multiplies 2 times 6, would not be correct, right? This means that base 2 is being multiplied 6 times. So 2 times 2 times 2 times 2 times 2, so to get 64, so Randy is correct. For Isabel says that 2 squared plus 2 cubed is equal to 2 to the 5th power, and Elizabeth says that 2 squared plus 2 squared plus 2 cubed is not equal to 2 to the 5th. So who's correct? So we can say that Elizabeth is correct because 2 squared plus 2 to the 3rd is 4 plus 8 or 12. And 2 to the 5th is 32, so they're not equivalent, right? So when we solve this, 2 squared is 4, 2 cubed is 8, that's 12, and 2 to the 5th is 32. So obviously, Isabel was wrong because they do not equal to each other.